Hi everyone, my name is Lokesh and today we are going to talk about one of my research project based on multilingual text detection in video and images. Myself, Lokesh Nandanwar, I am from India and currently I am studying masters in computer vision and image processing, and also I am a graduate research assistant at University of Malaya, Malaysia. I have been actively participating in competitions, hackathons in from my graduate days, and I have won Belt and Road Award 2019 from China. I have also won along with my team Smart India Hackathon 2019. I am being a part of Google Summer of Code 2018 as a student developer. Till now, I have published one journal publication in expert system with application and six conferences publication um, in recent. I have got two publication in ICPR 2020. Now, as you all know, we live in a digital age where we can see new digital devices are launched every day, new releases of new multimedia tools and devices with latest technology and with low prices. Also, the data storage facilities are now available freely or cheaper, and we can access the data storage facilities easily, such as Google Drive and OneDrive, etc. Similarly, with advancement of technology, there is an increase in digital lifestyle of the people, where people we can see many people, everyone are associated digitally. In Everyone is associated with the social media and internet and digital content. Everyone uses the news broadcast through the YouTube or etc. So the internet uses, basically the internet uses has increased drastically. So we need to automate the text detection and recognition for many useful purposes. So this text detection system is widely studied in pattern recognition field, and it is also known as automatic text detection and recognition, also called as OCR. OCR stands for optical character recognition. It started from isolated character recognition and evolved to printed handwritten document recognition. Recently, we can see embedded text in videos and natural scenes due to the increasing attention to the crucial information about the media content. And this extracting text from content is a non-trivial task due to many challenges. We can see the complete flow is like when you first we pass input image or video frames through the detector is used to fix the bounding boxes uh, for the text regions, and then the text region bounding boxes are passed to the recognizer, which recognizes that text bounding box into the computerized format. Then that computerized format text is used for many tasks, such as one of the example is translation, where when the computerized format text is translated to different languages. Similarly, for why text detection and recognition? Text detection and recognition is used in images and videos through captions for annotating it, for better indexing and retrieval at semantic level. For it is also used in recognizing signs in driver assisted systems, in automated cars or self-driving cars, etc. It also provides scene information to visually impaired people. We can detect the text and give in the form of voice or to them for visually impaired people. We can also use it for event extraction from sport and news broadcast. Also, we can use it for tracing and watching the persons with the help of the person's t-shirt number in marathons, exhibition, processions, etc. Our focus today is basically on text detection. It is the text detection is a process of detecting the text present in the image, followed by surrounding it with a rectangular bounding boxes. In case of arbitrary shaped text, we also use polygons or uh, curved box fitting. The image is segmented into multiple segments of text, where here we can see the green is the bounding box and it is segmented the character of Chinese. Here we can see numerals. Here we can see the Chinese text. Also here we can see in English. These are all text present, and it is fixed by the bounding box in green color. Each segment is a connected component of pixel with similar characteristics. These are called, in simple terms, these are characters. So far, the method developed have been focused only on some languages such as English, Latin, and Chinese. For languages like Hindi, Russian, Arabic, etc., which is also used by more than 1 million people around the world. The literature is very limited to very few studies. This presentation aims to tackle the challenges in multilingual text detection in video images with the help of Catalyst framework. Now, what are the challenges in text detection? First, the uneven lighting, where we can see the reflection of light in the image. So it is very difficult to detect and segment the text regions from here. In second is seeing complexity, where we can see the shadow of the sunlight present here, through which the text detection is very challenging. Next is uneven color. Next, blurring and degradation, which is caused due to the recapturing of images or the aging of the documents. Next is multilinguality, where we can see many types of languages used in a single images, where the fonts are different, and it is very challenging also when different fonts are present in a single image. Next is arbitrary shape text. This is also very challenging when the shape is very arbitrary. Here it is curved, but it can be of any shape. Now the existing methods and drawback. Some recent method, state-of-the-art methods we have listed here. One is FOTS, Fast Oriented Text Spotting. It is from CVPR 2018. It has the drawback of this method is weak backbone and weak segmentation head. Next method is Progressive Scale Expansion Network. It also has weak backbone and detector. It was presented in CVPR 2019. Another work is Craft, which is character region awareness for text detection. It also uses weak feature extractor of or VGG unit. It is also presented in CVPR 2019. Next work is DBNet, Differential Binarization Network. It also uses weak backbone from ResNet. It is presented in AAAI 2020. As you can see, these are all methods which we have listed here are from the very significant and very knowledgeable conference of CVPR and AAAI, which are recognized well in the computer vision and pattern recognition fields. Existing methods results, we can see here that the you can see the bounding boxes are not accurately fixed and tight and precise. Next, as you can see here, they are not the text is not detected properly. Half of the text is detected and the remaining text is not detected. Also, you can see the false positive, where the text is detected as the hand is detected as a text. The precise and the text detection, from this result we can infer that this is not precise and accurate. So we have to come up with a new method which is called FDB. This is our proposed method. First, the input image is passed through the efficient net backbone for downsampling, and we go from downsampling to upsampling using a unit decoder. And the unit gives us the two masks. One is threshold map and another one is binary marks. And these two marks are passed through the DB head, differential binarization head, to get the final segmented output. Our final result is this, where we can see precise, smooth, accurate, and tight bounding boxes for each of the segmented regions. All texts are segmented properly, and we have also significantly reduced the false positive cases. Now, why efficient net as the backbone? First of all, the efficient net is a net which is designed to neural architecture search, which gives us the optimal number of layers, optimal number of modules to be present in a neural architecture with giving the high accuracy with low parameters. Next, this model is based on the compound scale model scaling method is used, and which is using the effective compound coefficient, so that we can increase and decrease the size of the model without compromising the accuracy. This allows us to use different kind of models for different architectures, different kind of problems, such as if we want the real-time computation and we want the real-time performance, we will go for the lower end model, which is B0. And if we want to go for the tasks like medical imaging, where we are not care about the time, but we care more about the accuracy and robustness of the method, then we go for the high-end method like efficient net of B7 model. Yeah, and as you can see here, these are all the latest method which uses more parameters. The number of parameters are more, but the accuracy is less. But in case of efficient net, the accuracy is very high, even though the more number of parameters are very less, which implies that we can have the less training time and improving the real-time performance. It surpasses all the real state-of-the-art accuracy with up to 10x better efficiency. Uh, which in terms of smaller, in terms of size and speed. Why unit as decoder? Initially, it is designed for medical image segmentation, then adapted for fast and precise segmentation in most of the computer vision tasks. Most reliable and cost-effective decoder for segmentation tasks, and it performs better or nearly same than even most of the architectures such as DeepLab, FPN, FCN, PSPNet, etc., which is available from in recently. Then it has the less parameters, which is effectively reduces training and inference time. We uses dual mark strategy. In dual mark strategy, first is input image. First marks is called binary marks, and second marks is called threshold marks, threshold map or threshold marks. Binary marks is just a segmentation mask, and the threshold map is a border of the binary marks. This optimal strategy is used. We have found out that this is the optimal this gives us the best results for our text text lines and crowded text, where we have see the superimposed segmentation in general. And this also gives us the precise and accurate word-wise segmentation, which affects our recognition performance. Next, we use DB head, which is a differential binarization head. Instead of standard binarization, we use differential binarization. As you can see here, in standard binarization, there is only two values, 0 and 1. But in case of differential binarization, all we can see the all values are present here in effective manner. So we use it wisely. So the first major effect of DB head is differentiability, which makes the process of differentiation, binarization end-to-end trainable in a CNN. This is the formula we use for binarization. And differential binarization with adaptive threshold help us to differentiate text region from background, and also to separate text instances which are closely jointed. Finally, we use B-spline curve fitting. We explore B-spline curve fitting to fix the accurate and tight boxes for arbitrary oriented text lines. It fixes smooth and accurate bounding box for arbitrary oriented text, as you can see here. The accurate bound for 15 control point, it is fixing the accurate curve for and for the control points. For more results, you can see here. Uh, it is a multilingual image where Arabic text along with English text is present. Here we can also see some logos and the company symbols here. It is accurately segmented by our system, as you can see. So we can infer that this is of great import. This gives us significantly better performance than the previous existing methods. So now come up with the frameworks and codes. Frameworks we have used here is a PyTorch using the Catalyst as a high-level framework. Encoder decoder we have used from segmentation models PyTorch, which can be available in GitHub, which is available in GitHub. And for segmentation head, we use real-time syntax detection model from AAAI 2020. Datasets, here we are using IGDAR MLT, Multilingual Text Detection dataset from 2019, and ART 2019, which is Arbitrary Text dataset. This IGDAR MLT contains 10,000 images for training, and ART contains around 6,000 images for training. Finally, to validate our method, we have participated in active competition from ICPR 2020, which happened in Milano, Italy during September. It is based on superimposed text detection and recognition in Arabic news video frames. It happens along with ICPR 2020 in Milano. The results of complete public test data set for our competition is as follows. Rankings of this competition are awaited, but we are expecting good ranking for our system. We got the precision of 99.4, recall of 91.8, and app measure of 95.48. For more information about the competition, you can visit this link to get the more details of the competition and the rankings when they are published. In short, to summarize what we have done so far, first one is multilingual text detection is a non-trivial task and is the need of the today's digital world. First, then our second second is choose encoder, decoder, and head wisely while building an architecture in any computer vision task. Always validate the methodology with real world use cases such as competition, hackathons, etc. And finally, Catalyst is all you need to work effectively and productively in any MLDL projects. Thank you.